Hi guys. So in this project, we will be building a deep learning model that is to be trained on breast cancer autopsy images. That is a data set that we have to predict if the person has breast cancer or not. Right. To be exact, if the cancer is actually benign or malign. Right. We will then prepare our very own website that will be built using the Django framework and hosted on AWS. So let's get started. Now I'm going to move forward with the contents of the project here. We will talk about the overview. What exactly are we going to do in this project? Right, that would be in the introduction. Then we will talk about specifically which model we are building, what that model is going to do for us, right? Then we will talk about how we are going to create our website using the Django framework, and lastly, hosting it on AWS. So in this project, as I just mentioned, we will be building a deep learning model that is to be trained on breast cancer autopsy image dataset to predict if the person has breast cancer or not. Like exactly, it should be if the cancer is benign or malign. We will be using DenseNet 201, which is a convolutional neural network that has that is 201 layers deep. Basically, it has 201 hidden layers, right? You can load a pre-trained version of the network or you can retrain the model. And we will be using the later part, that is retraining the model, which we're gonna show you in the first step, that would be building the model, right? We will then prepare our very own website that will be built using the Django framework and hosted on AWS. Now, coming to DenseNet, which is the model. Now, DenseNet 201 is a convolutional neural network that is 201 layers deep, right? 201 layers deep. You can load a pre-trained version, or you can train the network again using your own data set, right? Now, the pre-trained version of the network is trained on more than a million images from the ImageNet database. Okay. Now, so the pre-trained network can classify images into 1000 object categories, such as keyboard, mouse, pencils, and many more classifications, right? So that is how we have taken a million images from different objects, or I would say for different objects, so that the DenseNet is able to categorize different objects, right? Such as mouse, keyboard, pencil, it could be cars, traffic lights, etc. Right. We can also retrain the model, which is what exactly we are going to do in this project. Now, DenseNet was developed specifically to improve the declined accuracy, okay, caused by the vanishing gradient in high-level neural networks, and it gives extreme accuracy for different classifications. But the thing is, to be noted, that DenseNet is a very complex and very, I would say, dense layered neural network. So unless you're providing it with a lot of information, it won't be performing to its maximum uh, value, or I would say accuracy, because the DenseNet, as it has 201 layers, it would require a lot of information to be fed into the model so that the model is able to generalize on the dataset properly. Else, it would not be able to do so, which would be clear too when we are building our own model, right? Now, the second part is creating the Django project. Now, Django is a free and open source web application framework written in Python. It includes advanced functionalities like authentication support, management, contact forms, comment boxes, which is basically handling the front end part, getting the data from the front end to the back end. Then we have the file upload support and more. In other words, if you were creating a website from scratch, you would need to develop these components by yourself. But by using this framework instead, these components are already built. You just need to configure them properly to match your site. Now, this is the last part, or I would say the last step, which is which is where we host the newly made website using the Django. Okay, we build the website using the Django platform, but we host the website with the help of AWS. That's a little misleading, but we will be using the EC2 instance for hosting the website and understand how exactly the virtual servers and the cloud system works. With this completed, we would be able to access our website and run the model from anywhere across the internet. So let's now move forward to the first step where we're going to build the model, or more appropriately, where we're going to train our DenseNet model through our own dataset. Hi, so this is the first part of the project where we will be building and training our neural net model, or more exactly training our pre-built DenseNet 201 model. So the first thing that you can see is the code block right here where I'm importing the drive function from google.colab. Now this is to be used if you want to access your files or subdirectories right from your collaboratory to your drive. Basically your collaboratory does not have the access to call things out from your drive, so you have to mount your drive onto collaboratory so that it gives off the permission to collab that you can now access any file or subdirectory inside this drive directory, right? So this is the code for that. Then we have a lot of imports right here, but I'm going to go for with most of the important ones. Okay, so let's start with the PIL library, which is Pillow, right? For Python 3.0, PIL was not supported, so Pillow was created as an interface to use PIL uh, sub packages or functions, right? Now, Pillow is built on top of PIL library, which is Python image library. And Python image library is one of the most essential modules for image processing in Python. So this module gives more functionalities, runs on all major operating systems, has a lot of support for different kinds of images, image processing, image handling, right? So it supports wide variety of images and their types too, like JPG, PNG, BMP, and many more. You can almost do anything on the digital image using the Pillow module, using the Python image library module only. Apart from basic image processing functionalities like point operations, filtering images, right, color spacing conversions, a lot of uh, other functions like changing the color sequence or shifting the image, extracting information from the image, all of that can be done using PIL package through in the Python language, right? Then we come back to TensorFlow and Keras. Now Keras is a neural network library, and it is an open source library software that provides a Python interface for artificial neural networks. Keras acts as an interface for the TensorFlow library, right? Now people sometimes get confused as to what Keras is, what TensorFlow is. Are they the same thing? So the thing is, they do provide similar functionalities, but they are working very differently under the hood, right? While TensorFlow is also an open source library only, uh, it provides various numbers of tasks for machine learning, for deep learning, right? But the thing is, TensorFlow provides both high level and low level APIs, while Keras provides only high level APIs, right? So this is the major difference for what Keras is providing in terms of uh, the functionality that it provides for you, right? Which is the deep learning and machine learning algorithms. But how it is providing you that functionality, that differs for TensorFlow and Keras. And for updated or new versions for the TensorFlow library, Keras is already embedded in the TensorFlow library only, right? Then we have the NumPy library, right, which stands for numerical Python. It is a library consisting of multidimensional array objects and a collection of routines for processing those arrays. Now using NumPy, mathematical operations and logical operations on arrays can be performed very efficiently, and the time that it takes for those operations to be performed on a particular array is very less too, right? So that is why we use a lot of NumPy functions when we are handling arrays or vectors, right? So then we have the sklearn library, right? So the sklearn library or the scikit-learn is a free machine learning library for Python. It features various algorithms like support vector machine, random forest, k-neighbors, and also some advanced classifiers like MLP classifiers that provides uh, classifications and also is based on neural network feed forward model, right? So not only that, but sklearn also provides you with a lot of metrics that you can use to gauge how well your application or how well your machine learning or deep learning model is performing, right? So you can even see here the metrics. And then we have the TQDM, which is just a library to showcase when we are running for loops or when we are running a process. It provides you with a bar of 0 to 100 so that you can see at which point we are on the processing, right? We are at 50th, that means 50% of the processing has been done. So we use that. For that we use TQDM. Now we have the CV2 library also, which is OpenCV. Again, it is somewhat similar to PL language. If I were to just give you an overview, right? It again provides you with a lot of functionalities that PL also provides, right? So this is too used for computer vision. Actually, more importantly, these are used for computer vision to process images, to extract information from them, or to build a prediction model or a classification model, right? Okay, so moving forward. Okay, moving forward. Yeah. So you can see I have created a dataset loader, right? I've created a dataset loader. So the thing is, uh, I have created a separate small dataset from the original dataset I had, which was kept in breast cancer, and it had two subdirectories which had benign images and malign images, right? Meaning the images for those autopsies for those people which were benign, which were having benign cancer, and similarly for the malign. So what I've done is I've taken a list, right? I've created a lambda function so that it converts my image into RGB format, right? So the first thing is that is happening here is that through the image, I'm opening the image. So in the in name, the path of the image is sent, right? The path of the image is sent, and then yeah, and then I'm converting it to the RGB value, which is red, green, blue, basic three colors, right? So we use convert. If you have put here L, right, so it would have converted into a white grayish format where it only takes into account the luminance in the object, right, which is inside the image. So we're taking the RGB format for now, right? And yeah, so what is happening here is that I'm reading the image, converting the image, then I'm working forward with the array data of the image. So basically we have a array data, right, which is explaining about the image, or I would say that we have converted our image data into an array data so that later on we can process this data and even feed it into the model. So that is what we have done. So we have taken the path, and on the path we get the type, right, format, if format and the name. So what is happening here is that in this we get the, let's say that this is the path, right? In the benign there's again a slash, right? There's again a slash and something something dot png, sorry, g, right? So what happens here is that your data gets split into a list of two elements where the first element is this and the second element is this. Okay, this here. So we have taken the second element and we are looking if it is png or not. If it is, then do read the file, right? Do read the file, and read is then running this lambda function So I'm getting the I'm opening the file through the open function, then I'm converting the value, converting the image into RGB format, and then I'm getting the array back inside IMG. Okay, then I'm sending the array data, and I'm resizing the image, right? So I'm resizing the image. Now resizing is basically the what should I say? Yeah, resizing is basically, let's say your original image was of a dimension 400 by 400, right? But you want that your image should be of the dimensions 50 by 50, right? We have just uh, shrink the image. So you use the resize function from OpenCV and you input the image and then you input the dimensions, right? So this is what I'm doing here. I'm resizing it. Then I'm just appending that into my original list so that I have all the values, right? I have all the values for the benign images and then for the malign images. So you can see that I'm getting the data here in the benign and malign uh, variable. Now I'm using what I have got in here to create my data set, right? So you can see that I'm creating our dependent and independent features. So we don't have the label, right? So we're creating the labels too for our data because we do know that this one is for benign, this one is for malign. But how would I tell my model that which one is what, right? So we are creating uh, basically we're trying to create a list which holds zeros and ones, right? So this is for that. We have created numpy arrays which we will merge later on. So you can see that that is what I have done in the next step only. So this was my independent features, right? The image data, this is my labels. So I'm concatenating it on the basis of rows. So what happens here, right? What happens here is that we have taken, okay, basically we have taken array A, array B, okay, and I have concatenated them on the basis of rows. So let's say that array A has 0 to 100 elements and array B has 0 to 100 elements. So 0 to 100 will be the values for array A, then 100 to 200 will be the values of array B. So that is what is happening here. So I have concatenated them on the basis of rows, and I have my uh, input data and my uh, label data right here, right? With the axis is equal to 0 means I have taken them row by row. If it would have been 1, then I would have taken them column by column. Okay. Now we are shuffling the data because, as you can see, the data is in a particular format. So the model might say that, oh, I'm getting, zeros again and again. So maybe the next value would be zero only. But it could happen that the values for zero has ended and we have come on to the malign part where the values are one. So, sorry, sorry. So it might happen that your model starts generalizing on this particular pattern only, which is not something that we want to happen. So we are shuffling the data, right? We are shuffling the data so that there's no certain pattern right here. Okay, now I'm using the two categorical function, right? I'm using the two categorical function to create the finalized uh, label data, right, which would now store two columns rather than one, and the column would showcase if the data is malign or benign, right? If the cancer is malign or benign. Then we are using the train test split model to get our uh, training data and test data, or training data or validation data for this particular model that we're going to use later, right? Random state is nothing but a value which tells train test split if you want to shuffle the data again or not while you're splitting it. Okay, if it's zero, then you don't shuffle. If it is any other number than zero, then yeah, you do shuffle it. Then we're just plotting some figures with the help of matplotlib, right? matplotlib.pyplot. So it helps in setting up images, or it helps in creating graphs with the help of GUIs. And we have taken some of the benign and malignant uh, autopsy images that you can even see here, right? So these are the converted, if you would go through your data set and if you would go through here, you would see that the images are a little different as to what they were before, right? And here you can see that the dimensions for it. So the dimensions are 224 by 224 only. If you would go back, you can see that the resize value I've given is 224 only. Okay, so you can see that here too. Okay, so we have come to the second part, right? We have come to the second part where we are going to pre-process the data that we have right now and finally feed that into our model. Now I'm going to cover this in the second part, and there I would also tell you about the DenseNet model and how we can, probably train it so that we get a higher accuracy. So see you in the next video. So this would be the part where we're going to transform our data and feed that into our model. So let's talk about image data generator. Now, many times while working on computer vision problems, we encounter situations where we need to apply some form of transformation on our entire data set, right? So the image data generator class in Keras provides a variety of transformations such as flipping, normalizing, etc. So not only that, image data generator also lets you augment your images in real time while your model is still training. So what happens is that you're feeding your data into the image data generator, and it is augmenting or changing the images, and then that changed or those changed images are fed into the model, right? So you can apply any random transformation on each training image as it is passed to the model. This will not only make your model robust, but it will also save up the overhead memory, right? Which you would be able to see in the code also. So you can see that I have some parameters with me, right? In the image data generator, we have the zoom range that is set to 2. So it zooms in the image. Then we have the rotation range that is 90 degrees. So it would rotate the image by 90 degrees. We have horizontal flip. We have vertical flips, right? So you can learn more about it by going to the image data generator docs. But this is basically these are those parameters which would help us in augmenting the images, right? So that we have a robust model through. See, so what happens here is that usually it might happen that you don't have a lot of data set with you, right? You might have only 50, 60 images and you want to create a model that is predicting very good. Okay. So the thing is that uh, you can use this image data generator. Let's say that the first image, which was of a car, right? You use the image data generator. So you would get the images of car only. But the thing is, in one image, the car would be, standing on its back. The car would be rotated 180 degrees, or the car would be zoomed in. So you would be able to see only images only. Sorry, windows only in the image, right? So this is how you would be able to create new data set from your existing ones, right? So you can create a large data set from a smaller one by augmenting the existing data set only, right? Then we're creating the model, right? We have taken the sequential wrapper, we have taken the learning rate to be 10 to the power minus 3. Then I'm going to input a particular model here. Then I'm going to add on the average pooling layers and the dropout layers. Then the last layer would be dense layer only, so that it predicts the final output of what the input data should be giving us. And the activation for that, or the activation function for that, would be the softmax function. So we are just compiling and taking the loss as binary cross entropy, right? And the metric is accuracy only. Now we have instantiated our DenseNet model. So the weights is for ImageNet only. Now there are two types of weights that you can use in DenseNet. We will be using the ImageNet weights only, right? And it is asking us to include the top layers too. So we have taken that as false. And now I'm telling them the shape of the data, right? What shape I'm gonna feed the data. Sorry, the data that I'm going to feed is going to be of what shape or what dimensions, right? Now I'm just going to build the model, but I'm taking the LR different here. Just notice that. And then we have the model summary. So with the help of model.summary, you can see that how many parameters are going to be used, right? Then, okay, so I'm going to use reduce plateau. I'm going to talk about that more in a bit. And here you can see that. So this is the most important part, this right here. So I'm using the fit generator, inside which I'm using the train generator, which is just an object for my image data generator. And I'm inserting the dataset here, right? So this is going to reshape the data, or I would say augment the data and then send back the data for training in the original deep learning model. Right, so I'm only taking 7 epochs and I'm taking a validation data too to see if my model is actually, generalizing well or not, or if it is overfitting or underfitting, right? So let's talk more about the model first before we move forward with the rest of the code or see how well our model is working. Now, DenseNet 201, right, is a convolutional neural network. You can load the pre-trained version or you can load the weights only and then retrain the model on your particular data set, right? Which is what we are doing here. Okay, so DenseNet was actually developed specifically to improve the declined accuracy caused by the vanishing gradient in high-level neural networks. What basically this means is that due to the longer path between the input layer and the output layer, right? Since there are a lot of hidden layers in between, the information vanishes before reaching its destination, that is the output layer. So basically, bits of information are lost, right? And the gradient, which should be updating after each passing through each iteration, you see that the at one point the gradient is not updating at all because the information that was required to update it has been lost throughout going through layers by layers. Okay, so an output of the previous layer acts as the input of the second layer or the next layer, right, by using composite function operations like ReLU or some other any uh, activation function, right? This composite function consists of convolutional layers too, pooling layers, or maybe batch normalization layers too, right? This is how the data transfer from input to output layer, and through the cycles, the weights get updated or refined, and we get a better accuracy throughout the model. But with the problem of vanishing gradient, we do not get the weights refined because the information for the updates is lost. Okay, so this is how. Okay, so the structure for DenseNet is defined in such a way that information is not lost, right? So your gradient is updated through each iteration, and that is why this is such a good model. But there's going to be a downside for it too, which you would be able to see right here. So as you can see, first, the model was taking a lot of time, right? Or it could be that my hardware sucks. But again, this is Google collaborating. So even there, after 7 epochs, each was taking along 3 to 4 minutes, and you can see that the loss was decreasing, and it increased. Then you can see that the validation loss was also increasing, but it started to increase, and there's a up and down here. But the main thing is that the validation accuracy was increasing, then it decreased, and it started to stagnate, and then it started to increase again. So the thing is, your DenseNet model is so complex that it requires first a lot of iterations to go over so that it is able to properly understand the data and then generalize on it. So you would first need to have a lot of epochs so that there's a lot of iterations for the gradient to update, and later down the line you would get a greater or better value. Then the second thing is that it might be that the dataset that we have used, right? If you would go back up, you would see that I only have 112 for my benign and 127 for my malignant uh, data, right? So it's a total of 230, right? Nearly 230. So which is a very small value compared to the DenseNet model because it was trained on millions of data, right? That is why you would require a very large data set before you can, properly use this model. But the reason why I've used this model is not because I wanted to have a lot of great accuracy or something. It was to showcase that TensorFlow provides you with even those kinds of models which are pre-trained, or where you can only, get the model and retrain some of the last layers. So TensorFlow provides you with a lot of different kinds of, I would say, models, deep learning models, machine learning models. They provide you with a model which you can train by yourself. They provide you with a model which they have trained. They provide you with a model where you can train only certain part of the model, right? Certain layers of the model. So there's a lot of combinations that you can use, and that is the purpose of using the DenseNet model here. Even here, as you can see that the accuracy is shit. Because if I were to say that my model has an accuracy of 54, right, 54%, which is basically around 50 only, and then this is pretty much a coin toss, right? I can just toss a coin and say that, oh, it's head. So yeah, man, you have a malignant cancer cells in you. So that is not exactly what we are trying to achieve here. It was just to showcase that we can, use even the most powerful tools without without understanding all of it, right? If we have to just get to know what exactly it is doing and how exactly it is working, right? This is all that you require to know, and then you would be able to even use the most complex models through the abstraction that TensorFlow provides, right? I would say encapsulation that TensorFlow provides. Okay. Anyways, so if you want to, really increase your accuracy, you can use even more images. So I've created two data set for you. One is the original one. One is the one that I have created, where I have differentiated the images in the terms of benign and malign. So you can just use a similar method only, but increase the number of images each of them have, right? And then retrain your model, and you might be able to see that your accuracy is going much higher as compared to this point course one. Anyways, okay, so the next thing that I'm doing is just creating or plotting functions which are helping me to see the loss, right, and the accuracy through iterations, how the loss was increasing or decreasing, right? As you can see, for the training, it was decreasing quite well, but for the validation, it was decreasing at one point, then it started to increase. And the accuracy is the reverse for that, which is not really that great, but still, you can see that there was a stagnation here, then we got an increase. Now I'm just saving the model and my train generator object so that I can directly use this later when we are getting the image from the user, and we have to pre-process that before we predict the class for the image, right? So I'm using the pickle library using the dump function from it, and the first parameter is the object, and the second is where I have to save it. So just I use the open and the path where I have to save it. Then model already has a dot save function, right? So you can just type in the path and save the model. Okay. So with this, we have completed the first part, that was how you can develop a dense net model, or how you can just retrain the dense net model using your own particular data set, right? Now, before completing this part or stopping the this session, I would say I would talk about a little on reduce plateau, right? So it is used to reduce the learning rate when a metric has stopped improving. Basically, you have your metric as okay, where is it? Yeah, you have your metric as accuracy, right? So if it is stopped improving at one point, as you can even see here, right? So if it has stopped improving at one point, even going through 2 3 cycles, then reduce plateau reduces the learning rate by a factor of, let's say, 2 to around 10, right? So what this does is that it starts to change the weights accordingly to see that now can we improve on the accuracy through learning more information or not. So this callback monitor is the quantity, and if it is not improved after it has seen for a patient number of epochs, the learning rate is reduced. So even here you can see that it might have seen that the accuracy was not increasing much. So it says that, yeah, man, reduce the learning rate so that the model is able to learn if it is not with the current learning rate. So you can see that after that it was able to do so, right? So this is what a reduce plateau is doing. Okay, so I've completed everything that I wanted to showcase while we were developing the model. Now, in the next part, I would talk about Django. What exactly is Django framework and how we can build websites on it, right? So see you in the next video. Hi guys. So in this video, we're going to start with the building of our website that will mount the that will mount the DenseNet model. So we're going to use the Django framework. So let's understand what Django is. Now, Django is a free and open source web application framework written in Python. A framework is nothing more than a collection of modules that makes development easier. They are grouped together and allows you to create applications or website from existing source code instead from scratch. So this is how even the simple designed websites that could be designed by a single person can still include advanced functionalities like authentication support, management, contact forms, file upload support, and more. In other words, if you were creating a website from scratch, you would need to develop these components by yourself, right? But by using the framework instead, these components are already pre-built. You just need to configure them properly to match your site. And how do you configure them or how do you use them? I'm going to tell you that in this video and in the upcoming videos, right, where we're going to use some of the existing functionalities that Django itself provides, and we're going to create additional functionalities by writing our own code in the Django platform itself. Now, Django has a model template views architectural system that keeps in mind the requirements of front-end and database management for a developer. We will see what this architecture means and how it makes things easier for a developer in the next video, right? We're going to talk about first how do you configure your project, right? How do you tell Django in what way the application has to behave, if it is going to be connected to some external applications or not. And in the next video, we're going to talk about this particular model template views architectural system that is helping us to create additional functionalities on our website. Moving forward, let's see how to instantiate a Django project, right? Now I have some steps written here and they fulfill two scenarios where one, you have to create or you want to create your own project, and second, you just want to uh, configure, or I would say you just want to set up the existing code base that I will provide you, right? I'm going to provide you with this my site directory which has all my Django code. So the first thing to do is create a virtual environment, right? I'm going to go forward with the first scenario where you want to create your own project. So create a virtual environment. If you're using PyCharm like me, you just have to go to File, go to Settings, a pop-up will open, and in that pop-up, you can go to the project, right? And you would have some particular directory, right, inside which you would store the store my code here. or if you want to create your own project, you would store there. So that would be the name of the directory here, project colon the directory name. Then click here, project interpreter, go to settings button, click on add, and it would again open up a pop-up to set up either a new environment or existing environment. Right, you can see that the virtual environment is already set up for me because the environment location is not empty there, and I'm using the base interpreter, that is Python 3.7.6. Right, so you can use that, or you can use the existing environment also. Then you just have to click on OK, and then you have to click on apply here and click on OK. Then your virtual environment would be set. The next thing to do is to install Django version, any version for that matter. You just have to type in pip install Django 3.2. This is for version. You can download 3, you can download 4. 4 is the latest one, right? So you can do that, and then you have to type in this particular command onto your terminal, that is Django admin start project, name of your project. Now the name of for my project is my site, so you can see that this directory was created, and inside that you would also see another same named directory to be created, which holds all the configurational files for Django. So you make your changes here to configure how exactly your Django application is going to behave. Okay, then once you have done that, right, once you have done that, just enter into the my site directory through the terminal and run this application. Sorry, run this here, Python manager.py. Start at and the name of the app. You can see the manager.py file is present here. So it has some commands which help us in creating additional things inside or configuring things inside Django. So the name of the app was polls. So this directory here was created. You can see that there's a different files are present here as compared to here. So the thing is, there's a difference between project and an app. Now, project is a whole structure that Django provides. Apps are basically subparts of those projects which provide functionalities inside the Django project or application itself. So you create your own apps, you use the pre-existing ones, right? So these are subparts of the project where you have your functionalities defined for your website. Now the next thing to do would be to set up settings.py file. I'm gonna go forward and tell you what exactly has to be set up here, okay, in just a minute. But then once you have done this, you can go forward with Python manage.py and migrate, right? Leave this command for now because this command is used to run the application, or I would say run a local host server for your application on your local machine. But let's say we are going with the second scenario, that is just to set up the existing code base, right? So what you have to do is just create a virtual environment, directly jump onto this pip install -r requirements.txt, right? I think I missed this part before, but once you have created your environment, just pip install the requirements, right? Because the thing is, your project needs some of the packages or some of the dependencies to run smoothly, and to do that you have to install the said packages. And requirement.txt, if you can see, has all the list of packages and their versions which are needed by this particular project, right? So running that command here would directly start installation for the each and every dependency or package. But in the second scenario, you just create your virtual environment, directly install the requirements.txt, run this command to install anything that is in the requirement.txt file, then directly jump onto here, python manage.py.migrate, right? Run this command and you're good to go. Then the next thing you will have to do is go back in settings and set things up there. Now let's move forward to the settings part. Here you can see that a lot of variables are created which are storing different kinds of values, right? So this is where you tell Django how exactly it has to work with itself or with other applications too. We have a secret key, okay, I'm going to go forward with the important ones, important variables or things that you need to know about or to set. So the first is the secret key, which is a unique key. Okay. Now this is specific to a Django project, and if somebody has the access to this key, they can make changes onto your application or how it is being run. Sorry, run. uh, right. So this is important, and we are using something that is os.environment.get. So the thing is, if you want to keep your secret keys or sensitive information away from anybody who might, hack into your code, then you create a .env file. So you specify your secret information here, which is not so secret right now. But yeah, set all your sensitive information here. And what happens is that once you run the code with the help of load.env function from the .env package, all of that secret information from .env file is sent to the system variables. Then the load.env uh, calls out actually the OS with the help of OS environment.get. We call out that sensitive information directly from the system only, right? And set the values in our code. So in this way, if somebody even has the access to your code, they still won't be able to get the secret key unless they have the access to your system too, which is hard to do so, right? So this is how you can keep your data secure, at least the sensitive information secure. Okay. Now you might be thinking that if somebody has the access to code, they can directly get the .env file, right? So the thing is, we delete the .env file once we have run the code, okay? So that nobody is able to access any secret information. Then we have the debug, that is the flag which can be turned true or false. So if it is true, then any error that your application has in its code, it would be showcased on the web page also. If it is false, it would only tell you the abstracted information like there was some system internal error or there was a 404, those status codes. So that is why it is also showing that security warning to do not run the debug turned on in production. Then we have the allowed host that is telling Django which machines can exactly run this particular project or access or connect with this particular project. Then we have the installed apps, right, which is basically the okay, as you can see here, these are the pre-built apps, right? They have the functionalities for admin panels, for authentications, for sessions. So all of these are handled by the pre-built Django apps, right? And then we have the last app, which is Polls, which was created by us to add on additional functionality that was not provided by Django, right? Then we have the middlewares. So Django also specifies the middlewares that it uses, right? So it is also handling the middlewares for security, for session, for CSRF view, which is the handling CSRF tokens through forms, right, on the front end. So it also handles middlewares. You don't have to you can explicitly type in or add on middlewares, but the thing is, you don't have to code it at least, right, from scratch. Then we have the templates, right? So templates is nothing but anything that is served to the user whenever the user hits a particular URL. So let's say that a user goes to www.google.com, right? So the page that is showcased to the user in Django jargons, it is called as templates. Okay. Then we have our database. If you were to use a third party application, sorry, and that would be like MySQL or Postgres, then you can even connect that application to your Django application with the help of specifying the port on which the connection is going to happen, the username, password, right? With the help of that, you can connect to your database, external database, and also handle your database through the Django application itself. So you don't have to make changes here, then go to your Postgres or MySQL, then make changes there. Then we have the cache system, right? So Django also provides you with the cache system, how exactly Do you want to set your cache system, what exactly is to be stored there, right? And the last part that is important is setting up a media URL and media route. So media URL is basically a path on the web page where you can access all the images or files that you have saved or taken from the user. And the media route, right? The media route is the path where I would say the path to the directory where your data that was the images or files the user input would be stored. So as you can see, it is going to be stored in polls my data. So you can see there's a my data directory here, right? Which has another my data directory here, which has all my images. Okay. So with this, uh, all of the all of the variables that I've gone through, these are what you have to set up so that you can run your project smoothly, and the configurational process of setting the application is also completed. So with this, I'm going to complete. I would say I'm going to stop this video right here. And in the next part, we will talk about the model template views architectural system that helps even handling the front end and database management for a developer. So see you in the next video. Hi guys. So in this video, we're going to start with the explanation of model views template or any of the three combinations like template views model architectural system, right? And how exactly is it helping a developer to even handle the database management and the front end part? How is it making things easier? And why is Django employing this particular structure? So you can see I have my views, and views are particular to apps. Okay, they are particular to applications. You won't find any views inside your uh, configurational files inside your project directories. That is because views are exactly what we use to create new sorry, I would say new functionalities for your application or for your website. So the additional functionality or the new functionality that we have for our website is predicting the benign or malign class for an image, right? So how are we going to do that? We have the views, models, and the templates. Again, templates is nothing but the uh, anything that is served to the user when he or she particularly hits a URL. So you can see that we have the templates here, right? And in the templates, we have the index.html and we have the upload.html. Now in the views part, you can see I have created functions, right? Some functions right here. And you can see that there are two functions which are taking request parameter only. And then there are other functions which are taking other parameters. So I do focus about those functions which are taking request parameter because these are particular for Django and these are what help us in creating and running our website. So any function that is taking request as a parameter will also have a render function's output as return value, and the render function will take request and then the HTML page, right? So each function is mapped to a particular HTML page, and I will talk about this later. So right here we have a function which is taking something, handling some things, and then it is rendering my HTML page, which is the index.html, right? In the upload you can see that similar things are happening, and we do have a render function here too, and it is handling the upload.html. So each function that is taking a request parameter is handling a particular part of the templates or of the front end, right? So you can see that whenever this function is called, this index.html page is rendered or is served to the user. So this is what is happening here. We will talk about what is happening inside the function later. But for now, you just have to know that views handle the backend part of your project, and there we have a function which is taking a request parameter, and if it is taking a request parameter, then it is mapped to a particular HTML page or particular part of the template, and it is helping rendering that. So you can see that the function here is created, the function here is created, but we can't see any call for the uploading function or for the handler function, right? They're just instantiated and defined here. So the thing is, we call them through the urls.py file. Now here you can see that I have a function path, which is taking the, again, path, and then the handler function. So what is happening here? So the thing is, the path is mapping on which URL which function is to be called. Meaning, let's say that you go to www.home slash. Okay, this is not a great example. Let me just use the local host URL only. Right, if you go to this URL, right, if you go to this URL, Django understands that I have to call this function. Then this function is called, and in this function it says that, oh, I have to render the index.html page. So it would send back the HTML page, and then the user is able to see the HTML page. Right, so this is how you go to a URL and you're able to see the page in Django. Okay, so this is what is happening here. Then let's talk about the models, right? So we were able to see how the views and templates were working together. So let's talk about models. Now models is nothing but the, okay, so models is nothing but the uh, tables, right? The tables that you create to store in values. Uh, So we have our class input emo. Okay, this is not exactly the greatest or the best name, but this is the table name, right? And it has certain columns. So these are what we call columns, right? The table has these columns where there's an ID which we will uh, use it as a primary key. Then you can even see that here. Then we have the name for the file, date when it was uploaded, and the file where the path of the file where it is uploaded, right? So it is uploaded to my data. So in the media part, right, in the settings, we said that it has to be stored in pol/media my data. Inside my data, the file here, understand that I have to still store the data to my data. Uh, so it again creates a my data folder. Inside that you can see all the files present, right? So this is what is happening here. So what is happening here is that we save the data, right? We save the data inside our tables, and then we call the data here. So you can see that I have imported my table, right? And I'm getting the objects from my table in a certain fashion. So here, now let's talk about what is happening inside this function. So once the user has input the data through the HTML page that we just rendered, the data gets stored in the models or the tables, and then I'm calling that table data here, and then I'm sending that table data into my transform data, right? Into my transform data function. So scrolling down, you can see there is a transform data function, which is again helping me, with the resizing, with the conversion, right? So this is what is happening here. Then once I get my data, right, once I get my data back, I just get that in an NP array and then use another function predict. So predict is calling or loading my breast cancer model. Then it is predicting the data and returning back the classification. So I get that back in my results here. Then I am just printing it and sending it back. So what is happening here, right? I was talking about explaining this later. So the thing is, now you have manipulated or now you have gotten your results from your data that you have saved before. So the next thing is to show back this particular result to the user, right? On the front end, on the page. So to send back information from the back end, which is our views, to the front end, which is our index.html right now, we create a dictionary which is called context, and in the keys we send back the results as values, right? So here you would be able to see that I'm using that here, and if my response is 1, then the category is benign. If my response is 0, it is benign. If the response is neither of them, that means that you haven't input the data. So this is how the views model template architectural system is working with the help of each other. Since they're dependent on each other, a person can manage the models. So in that way, he is able to manage the database, right? Since all the tables are created here, you can even type in constraints for some of the columns right here, right? like we have said that this is primary key, it is going to act as primary key. You have to set the default as this, right? So you can do that here. Then we have the when we have the front end part, which is the templates, right? Inside templates you can see the index and upload HTML. So we are handling the front end too, right? So if I go to the upload.html, you can see that okay, this is a lot of CSS. Then we have our forms, right? So forms is what is taking the data from the user and then sending it back to the backend. So you can see that there's no input tags right here, right? There's no label, nothing. There's just one form.asp. So the thing is, we have created forms, which is a functionality that Django provides, where you don't have to create a form explicitly. You just have to tell Django that Django, you have to create a form and you have to take these values from the user. So Django understands that, oh, okay, I will just create a template in onto the front end, which is going to showcase the user that you have to input both of these values. So you create a form, then in the form you tell them that which model has to be referenced, meaning that once the data is inserted by the person, right, on the front end, then where do you have to store these values at, right? So you have the model, you have your table, then the fields from these tables which have to be inserted or which have the data in which has to be inserted by the user, that is the name and the file, right? Then it is automatically stored inside the models. Then we in our views take out the value which was stored in the model and then perform our manipulation and prediction, right? So this is how the Django application is working, right? Now I have also created a sustain.py file, which is the cache system. Basically here you're telling Django that I want to store something in cache, right? So we create a key object pair where we create a key and we then tell the object what has to be stored inside that. So once you create your key, then Django directly calls onto this object with the help of the key only, right? You don't have to insert or load your files again and again. So with the help of this, whenever you reload the site, it is not that you would, once you reload again, the pickle.load function will load the image generator model, right? Image data generator model. It would directly call the image data generator model from the cache. So this takes less time. So it makes your site reload faster, more responsive too, right? So this is why I've created the cache system. Now you might be thinking why I've done the same thing for my model, right? Why I'm just loading it again and again. So the thing is, cache does not support the .h5 files, right? It does not store the h files properly. So you have to load this one. Or what you could have done is that maybe saved the breast cancer model, deep learning model as a pickle file too. Then you might have been able to do the uh, to use the cache system. But we haven't done that for here. Okay. Now this is yeah. So this is what we are doing here, right? This is what we are doing here, and with this, we can say that we have completed the second part or second step of our project, that was creating a website using the Django framework, right? So we have our Django application, and the last part would be just to shift our application from our local machine to the virtual machine, right? And host our website there. So I would start with that process in the next video, right? So see you in the next video. Hi guys. So this is the third part, or I would say the third step, where we're gonna start off with hosting our website. But before moving forward to that, in the last part, I didn't mention how you would, see if your site is working properly or not. So what you have to do is you have to run the command python manage.py run server. Okay. And what this will do is that it would create a it would create a development server for you on your local machine, so that you can see how exactly is your website working, right? If it is functioning as required or not, if you're getting some errors, or if it is, going smoothly. So it performs some system checks to see if the Django application is working properly or not, right? Once it does that, it would give you a localhost URL and tell you that the development server is now running on your local machine. So you can just click on this, or you can just copy paste it into a URL, into a browser, and you would be able to see a page which says page not found. Why? Because we have only registered for home and for home/upload URLs. So if you go to home, right, you can see that we have our page right here. You can just click on upload, and you can just type in the name, which could be image3, right? You can just choose the file, and okay. So I have my data, right? So I'm just taking a malignant image, autopsy image. Then I'm just clicking on submit. Now this will take some time because you're loading your DenseNet model and then running the data into it, feeding into it so that it predicts. So this will take some time for doing that. And once it has done, you would be able to see the dashboard page only, but in there you would be able to see the class it has predicted for you, right? So you would be able to see that. Okay, it is taking a lot of time, and I think it is taking more time because I'm running OBS on my shitty laptop, right? So it is loading even slower than compared to before. But yeah, you can see that once on your PC or laptop, once you run this code and with the help of Python run server, right, the run server command, and you test out this side, you would be able to see that you are redirected back to your dashboard page, and there you are able to see the class uh, which was predicted by your model for the input image that you had given, right? So you would be able to see that there. I'm going to stop this because it's loading like for eternity, right? I'm going to show you the same thing when we host our website, right? So there you might be able to see it better because my dumbass laptop is not able to work on this. Okay, anyways, so I'm just gonna stop my server right here. Right, even here you can see that it has started, but still it hasn't loaded the server properly. Anyways, okay, moving back to AWS. Now we're gonna use AWS and its services to provide the hosting platform, right? So Amazon provides the elastic compute cloud compute service, right, which is known as EC2, and they provide some of the features that you should know about so that you are able to configure, or you're able to understand which instance or which type of instance in the EC2 you should use, right? So the thing is, once you log in into your account, you would be redirected to the AWS management console, right? So from there, you just have to type EC2 in the search bar, and you have to click on the first service box they provide here, right? So just click on EC2 here, and you can see how laggy and slow my laptop is. Anyways, so you would be redirected to the EC2 instance dashboard where all the instances that you have, started or initiated at some point but stopped are listed here. So you would be able to see that. But if you're using the AWS account for the first time, or you haven't instantiated any VM, then this would be pretty much empty for you. So the thing is, what you have to do is you have to click on launch instance, right? There's a button for launch instance. So click on that. So once you click on that, it would take you to the page where you can create your instance. But before that, let's understand the features I was talking about that the EC2 provides. Now they provide you with a pre-configured template for your instance, which is known as Amazon Machine Images, AMI, right? That package the bits needed by your server, which might include operating system or some additional softwares, right? Like Python, you might want to use Python. So it already installs a Python version for you inside the VM with the help of AMIs, right? Now they provide you with various configurations of CPU, memory storage, networking capacity for the instances, right? So on the basis of these configurations, they have created types, which you would be able to see in just a minute. Then they provide you with a secure login. They create a key pair, which acts as a password that can be used to log in into your virtual machine from anywhere, right? From any remote machine. Then they provide you with storage volumes for temporary data. They provide you with persistent storage volumes, which is also maybe known as Amazon EBS volumes, right? So they provide you that. They provide you with a firewall that enables you to specify the protocols, ports, and source IP ranges that can reach your instances using security groups. This is important too because with the help of the security groups and the rules that we define, we would be able to tell the VM that only these people or only these things can associate with you, can connect with you, right? So this helps us in securing the VM too. Now let's move forward to create a virtual machine on Amazon, right? So we have to choose the AMI, right? The Amazon machine image. I'm going to choose the Ubuntu 20.04 LTS, right? They provide you with Windows 2, with Red Hat 2, and Mac OS and Amazon Linux. So I'm going to go forward with Ubuntu, select. Then they would provide you the types which you want to go forward with. Now for this particular project, go for T2 small. As I told you, DenseNet is a very complex and very high hardware required model. So T2 micro won't be able to manage. So go for T2 small, right? As you can see, this is not in free tier as compared to T2 micro. But once you have created your account, right, on Amazon, they would provide you with some free credits. So you can just directly use those free credit for your T2 small version. Then you can just directly click on review and launch. But if you want to go forward and configure your VM to an extent which is not provided by normal review and launch, then you can do that. You can type in the number of instances you want to use, right? Then there's also the network that you want to use, the subnetwork that you want to use, then monitoring if you want to have CloudWatch monitor and tell you what is exactly happening, how much CPU usage, how much basically key inferences for your VM to understand if it is overloading or not. Then you have advanced details too. Okay, then you can move forward to add storage. Let's say, okay, so the thing is, Amazon provides you with a default value of 8 gigs of size. You can go up to 30, right? 30, and still stay in the free tier eligible part. But after 30, you might have to pay for it. Okay. Then you have the volume type. There are different volume types too. 8 is pretty much good for us. So I'm gonna go forward to tags. Okay, so tags are basically the right. So tags are basically um, kind of a filter which can be used to say that maybe these two VMs have the tag of machine learning. So a machine learning model has been, hosted there. Then these two VMs have a tag of Django. So that means that Django side is hosted in these two tags. So you can group together different VMs with the help of tags. Then you can click on configurations for networking, right? Security groups. So we have the network security groups here, which has a protocol already set for us. You can even uh, create a new rule, right? But I would be showing you how to add, delete, or edit rules later, right? You don't have to do anything here. You can just click on review and launch, right? So once you do that, okay, it is also telling me that yeah, your configuration is not eligible for free usage tier. Anyways, this would just give you a brief of whatever you have chosen. Then you can click on launch. Then once you click on launch, it would ask you to use an existing key pair or a new key pair. So go for new, then click on RSA type only, then type in the name for your key, right? And then download the key pair. Now this is very important because this is just like your password. So keep it safe and keep it secure, but also keep it in a place where you can access this, because with the help of this key pair, we will be SSH into, or we will log in into the VM, or this will also help us in transferring our file from a local machine to our virtual machine. So once you download this, it would get you the launch instance button ready. So just click on that and it would redirect you back to your EC2 dashboard, right? And you can see your new created instance there. So I'm going to click on cancel because I've already instantiated one. Okay. And you would be able to see that. Where is it? Yeah, you can see that here. Right, so I have the T2 small one and it is running. So you would be, once you click on select this, you can even see the details, security and stuff. So in details, you can see the IP v4 address, right? There's a public and there's a private one. There's a DNS for that, and there's a VPC ID, subnet IDs. Then they talk about your instance type, if you're using an elastic IP or not, if a particular IAM role has instantiated this or not. If it's root user, then it won't show you anything here. Then the platform and stuff like that. Then you can go to security. You can see the security group that was created when we created the VM. Then there's inbound rules, then there's outbound rules, right? So before moving forward, let's talk about some of these terms. Now, DNS is domain name system, which is a standard by which names are used on the internet and they are resolved to their corresponding IP addresses. Which means that let's say that we are going to www.example.com. So there's a tree structure defined, and what the browser does is that it tries to see which particular IP address is mapped to my example.com. So it gets that IP. So once it gets that IP, it is able to understand that I have to connect to this particular server which has this IP. So it goes to that server, establishes a connection, gets the required information, and then sends it back and shows it to the user on the web page, right? So that is how you're able to go to google.com and then you're able to see the web page there. So this is how DNS helps us, because rather than directly typing the IP in the URL, you're able to just directly type in google.com, which is also easier to remember and understand. Then let's talk about the inbound and outbound rules. Now, a security group acts as a virtual firewall, right, for your EC2 instance to control incoming and outgoing traffic. Inbound rules control the incoming traffic and outbound rules control the outgoing traffic. What I mean is that inbound is handling all the incoming connections coming to your EC2 instance from anywhere across the internet, right, or from any other machine. And outbound means outgoing connections, that is EC2 sending out connections or trying to establish connections with other machines over the internet. So we can set up rules so that only certain things can access our VM, so that makes it more secure, right? Then we have the VPC. What is VPC? VPC is Virtual Private Cloud, which enables you to launch web applications and web services provided by Amazon into a virtual network that you have defined, or by default they have defined, the AWS has defined. This virtual network resembles a traditional network, right, that you would operate in your own data center. Uh, I can, yeah. Uh, You can think of VPC like an apartment where your furniture and items are analogous to database and instances, right, that you are using in your AWS account. And the walls of your apartment isolate and protect your things from being accessible to other tenants, right? So similarly, VPC helps in segregating and separating and isolating the services that you're using from other users. and also other services that you're using from each other too. So VPC is helping in that way, right? So that is why there's a particular VPC ID for you and there's a subnet ID for you, right? So let's talk about how to make changes or add rules in your security groups, right? Because that is important. Why? Because Django needs the permission to connect with your VM or create an establishment with your VM so that your application is able to be run on the VM, right? So in the security, go to security groups. There you would be able to see all the list of rules in the inbound and the outbound rule, right? There's the inbound rule here, there's the outbound rule here, right? So in the inbound rules, click on edit inbound rules. There you would be able to see add rule, click on add rule, then let it be as custom TCP, and then in the port type in 8000. In the custom, let it be anywhere IPv4, and you can just type in some description for it. So as you can see, I've already created a rule that would let or that would handle the connections for Django and the VM. Right, so you can just type in them and just click on save rules. Now I'm not going to do that because there's already a custom one made, right? Then once you click on save rules, you can just go back to your instance, right? Go back to your instance, and now, okay, go back to your instance and in details, remember this public IPv4 DNS and public IPv4 address. In the code that I provide, it would be written, this particular DNS and address would be written. So you have to make changes and write your own addresses there, okay, in the .env file, so that does not, create problems for you later. So I'm going to stop here because we are now at a point where we have instantiated the VM, where we have configured the VM. So the next step would be to transfer our files and set up the Django application inside the VM. But for doing that, you have to download and install certain applications. So the first is PuTTY, right? So download and install that. Now this is a free SSH and Telnet client which would create a console through which we would be able to run and set up the code inside our VM. The next is PuTTY Gen, right? Next is PuTTY Gen. You have to install this too. So it helps us in creating SSH keys, right? Or more importantly, create private keys which can be used as password. Then the last one is WinSCP. So WinSCP is a software that will help us in transferring our files from our local machine to our VM, that is the virtual machine. Right, so install all of these, and in the next video I'm going to use these particular software so that we are able to host our website. So see you in the next video. Hi guys, so this would be the last video for this project, right? Because we are at a point where we can now just transfer our files and set up the code inside the VM. And finally our website would be running, right? So I want to show you that too. So the first thing to do for this is to open PuTTY Gen, right? And in here it gives you an option of either to generate a key pair or load an existing one. Since we have already created one when we were launching the instance, right, on AWS, we will go with load, and inside load you would get an option to browse where you have saved your file. Now I had saved them in the code file only, so click on all files so that you're able to see the file, and here you can see the file which is the PEM file. So a PEM file is generated by AWS. So we have to click open that, and then we would have to click on save private key, then click on yes, right, and then save the file in a place that you can access. So I have the file already saved that you can see here, breast cancer private. You can see the file is of a PPK format, that is PuTTY private key file. So just click on save, right? And after that, the work for PuTTY Gen is complete. And the next thing is to run the WinSCP. So WinSCP is the software that helps in transferring of your files from your local machine to your remote machine or your virtual machine, right? So just okay, for you it would open a new session, right? In the new session it would give you a pop-up, right? Then there you it would ask you to type in a host name. So your host name is actually the DNS name. You can even use the IPv4 address. These are the same thing only. So just paste it here. Your user is Ubuntu, right? So by default, the user is Ubuntu if you're using the Ubuntu AMI from Amazon, right? Then for your password, you have to click on advanced, and here your private key file that we just now generated will act as a password. So go inside SSH, go to authentication, browse your private key file, right? PPK file, and just select that file, click open and click OK, then click login. Okay, so it would ask you, yeah, it would give you a pop-up to ask you for permission. Just click on yes. After that, you can see that on your left-hand side, you have the local machine. On the right-hand side, you have your virtual machine, right? So if you since we had logged in as Ubuntu, you can see that the rights for here is less as compared to the rights for here because this is the root and this is the Ubuntu one, right? Now, how do you how do you transfer the files? It's pretty easy. You just click, select and drag and drop here. So once you drop, it would ask you if you want to upload the my site directory into home/Ubuntu. So you just click on OK, right? So once you click on OK, it would take some time and just load it, and then your code is also transferred from your local machine to your virtual machine. The cool thing about this is that let's say that you have to make some changes in requirement.txt file. You can just double click and open it, and an editor will open. Then you can make some changes here, right? You can make some changes here, and then just control save it and close the file. And then you can see that your changes were also transferred, and now the changes are set in your virtual machine. Let's say that you have to find some files, right? So I want to find the NV file, and just click on start. You just name your file here, then you can click on start, and then it would find where your .env file is present, right? You can just click here and you can even focus on it, or you can just edit it, right? So you can do that too through here. So it's pretty good overall, and it helps us in transferring the file, which is the main thing. So you can even delete some things, right? You can just click on here and delete it. So this is how we are able to transfer our files. Now moving forward, right? Moving forward. Okay, either you can let it stay open or you can just close it because the work that would have to be done by this software is completed. That was transferring of our files. And the next thing to do is to set up the VM or our code inside the VM. So for that you run the putty. Here again you type in the host name and you go into the SSH, right? Inside the SSH you go to authentication. Inside authentication you click on browse, and in browse you again select the private key file, that was the putty private key, and click on open. Now you have to log in as Ubuntu and you are now inside your virtual machine. Now you can see that the system load is this, the usage is 51%, that is 51% of 7.69 GB, right? The memory usage is 15%, and there are this many processes running concurrently right now. So now we are at a point where we have to set things up, right? So I'm going to run some commands that you can use to set things up. First is the ls-a. This is a Ubuntu command to see all the subdirectories and the list of files that are present in the particular directory. Then we have the pwd command to see in which directory we are currently right now, right? Then we have the df-h command, which tells you how much of space has been used, how much is available for the different disk spaces. Then we have the free-m, which tells you that the total memory that we have, how much of it has been used, how much of it is free, right? Now there's also a buff cache system, right, which has some parts where you can store things up. So we are also using cache, so this would be used, right? Now we talk about the sudo command. The sudo command actually precedes all other commands, and sudo gives you administrative rights onto your machine. So it runs your commands into super user mode, right? Which is helpful when you don't have the access or the rights to run certain commands for updating files, for updating packages, for installing packages, right, on your machine. So I'm going to show you why this is helpful, right? But the thing is, even in your project, right? Even in your project, when you have shifted the project here, when you have instantiated your VM, right? So Python is already installed on your machine. You can see that Python 3.8.10 is installed, but the problem is that pip is not installed. So you cannot directly install all your requirements from your requirement.txt file on your virtual machine. So for that, you have to run this command, which is sudo apt-get. It's either updating if it is already present, or just install Python 3 pip. Okay. So if you run this command without pip, right? If you run this command without pip, you would see that I'm getting an error, right? That the permission is denied. So if I run this, okay, if I run this command with sudo, you would see that I'm able to now uh, run this command properly. And yeah, okay, so the thing is, since I've already run this command, there's no new upgrades or newly installed things. But for you, it would take some time. It would again ask for your permission. So type in Y. So once you are able to done that, or once you are completed with that work, then you can start off with installing all your packages through the requirements.txt file, right? So you run the command. Okay, first you have to go inside the my site directory, right? Because the requirement.txt file is inside there. So you run the command. Sorry, pip 3 install dash r requirements.txt. So you run this command, and all the requirements or all the packages and dependencies required by the project will be installed on your virtual machine too. You might get some errors that I got, right? You might get some errors about Launchpad. So if you're getting that error, right? If you're getting that error, then you just run this particular command here. That is the installation for uh, installation for test resources. So you might get an error for Launchpad. This would resolve that error, right? This would resolve that error. Now, if you're getting another error about the OpenCV, then run this command. So because the thing is that we were working on Windows, right? So some files are configured differently on Windows and on Ubuntu for Linux uh, Python packages. So run both of these commands if you're getting some error. So this would also fix that error because there's an error in libgl error. The package, this dependency, to be exact, is not able to run something because the files are not updated. So this would install all the files or either update it. Okay, so run them, and okay. So once you have run this, also you have completed your uh, setting and installing of your dependencies. Then you have to run the command python 3 manage.py make migrations. Okay, make migrations, right? So it would see if you have made any changes in your tables or not. If there's no change, then it would tell you no changes detected. Then you run the command migrate to instantiate all the tables inside your machine, right? Since the tables were only created inside the SQLite 3 database provided by the Django in our local machine. You have to again do the similar thing here so that the tables are present here too. Then the last command is to start the server, which is run server. Okay, run server 0.0.0.0 colon 8000 because we are working on 8000, and Django by default connects on port 8000. So this is why we had to add a rule, add custom TCP for 8000 port 2. So right, once your server is up and running, just copy the public IPv4 DNS, go to your browser, type in the port /home, and here you would see that your site is now getting loaded, and now you can access your site anywhere across the internet on this particular DNS or URL, right? So click on upload the file, type in the name, which could be image2, then click on choose a file. So as you can see, I'm choosing the malignant file here, right? And I click on open, and I click on submit. So after submitting, now you can see that your model is getting loaded. Then the data that we have transformed will be feeded into the model, and the model is going to predict back the results, and we can show the results back to the dashboard. This will again take some time because DenseNet model is very heavy on the VM, but you can see that, yeah, here it has completed the process. So you can see that the category is malign, right? So with this, we have completed the last step 2, which was hosting our website on the Amazon instances, right? On the Amazon Web Services, through the Amazon Web Services, right? And now you can just locate your website using this particular DNS and try it out, right? So I hope you like this project. Okay,